Okay, we're on the record.
All right. All right. Today is the last day of May of 2024, May 31st, 2024, just for the record. I'm Don Weiss, and to begin with anyway, I'm going to pose this as an interview with my partner, Jeff, who's been doing some very interesting reading lately and thinking, I might add. In an area that interests a lot of us, myself included, the question of survival of death, sometimes called the problem of human immortality. Those two things don't mean exactly the same thing, but all sorts of questions arise under this heading, and it gets so confusing that it doesn't matter, it seems to me, where exactly we begin. We should just start talking about it. So I think, Jeff, a place that is as good as any to begin with is what I said. I've gotten intimations from you that you've been doing some interesting reading in the fields pertaining to human immortality or survival of death and so forth. I'm going to just stop right there and ask you, what's up? What have you been reading? What do you find interesting? Any new ideas in this sector, whatever you want to say?
Well, in general, I've been looking at the intersection of, I guess you'd call it science and spirituality in a very broad sense, and have not been very pleased with the dialogue that has been occurring, because it seems that both science and spirituality have gotten entrenched on their sides of the fence. And I would say they're kind of both to blame. They're not really looking to see what one area is doing and seeing how it might affect them. And the one area I've come across that has really changed the dialogue, I think, between science and spirituality is the new concept that we have now of information that has basically come about. Started off with Shannon back in the 50s, who really started to mathematically define what information was and really kicked off, I guess, what we would call the information age right now. But I find this very meaningful in terms of a dialogue between science and spirituality, because in essence, when we think about human consciousness and the components of spirituality, they are basically non-material and non-local, in that it appears to be a slightly different realm of information. And information fits quite nicely into what I would call the spiritual realm. It is information that makes us who we are, our memories, our experiences. And you mentioned what survives death. Well, people would be interested in, if anything survives death, it would have to be information, who we are, what we did. It would be pointless to pretty much live on after death if we had no idea who we were. So the whole idea now that we have about information and what it consists of really fits quite nicely into what we would call the spiritual realm.
And how it can be stored in memory. I mean, I take it that if we get into this, we're getting into the whole field of of modeling all of this on a world of electronics, in which, moving from information theory, as soon as you started talking about things as if we can deal with things on the level of information theory as fundamental, then what is it that we cannot store? If it's information, we know information, even complex information, can be stored. As to where it's stored, by the way, you referred to the fact that it may be non-local. But why not? If the DNA, if each cell of the body contains the genetic code for the entire body, as it does, Then we have holographically. We can get into a whole discussion of the metaphysics of holography here, but it seems to me quite in line with a lot of recent thinking to say that yes, you can have memory being non-local. Pribram's work on the brain, his groundbreaking work, which showed the holistic character of memory, that actually in human experience, memories are not localized at one particular point in the brain, but are spread out, contained in one place, so that if damage occurs in one place, you can access it from another place. It's very holistic, holographic, if you will. So that part of it intrigues me. It seems to me then, well, we could turn the tables. And why not just say that the whole field of information theory, as augmented by transmission theory in radio, transmission and reception theory in radio, and processing and memory as we see in computers, the whole world of electronics, as I said, including radio and computers, models exactly all we need to believe, for example, in human immortality.
You mentioned a number of key concepts here. One of the first things that's interesting about information is, excuse me, it's pretty much a consensus now that information cannot be destroyed, which would be a very nice thing to believe in, since that if you're going to live beyond death, it'd be nice that that information is not destroyed. But you've also mentioned some other key questions that are worth investigating. Where is this information stored? If it's not stored in our brain, obviously, if it is stored in our brain, then it disappears with death. But if it turns out it's not stored in our brain, then that means that the chances of having some sort of consciousness beyond death is very much improved.
All right, that brings up, you have to explain a little bit about what you mean here, because people who might be looking at this might wonder what you mean. Where could you're suggesting that a lot of what we call mind occurs not on the premises here in the body, but is brought in. That's where this receiver analogy, to get back to radio, you're invoking now this notion that we are a receiver of information which actually resides or comes from something out, a place, the cloud, as it were, outside ourselves. Is that fair?
Yes, there are a number of philosophers as well as scientists now. You mentioned Pribram, who was a brain researcher who spent almost 70 years. He lived till he was 94, and he spent almost 70 years of his life studying the brain. He was actually called the Magellan of the brain. And towards the end of his life, he came to believe that he started out thinking that our memories were stored in different areas of our brain, and if you stimulated those areas, you would remember things. But as he investigated more and more, he started to look at the brain as more as a receiver of information, that the brain was not storing any information locally in the brain. It was acting as some sort of receiver for information coming in from somewhere else. To put it in today's verbiage, all of your memories and everything that makes you you is stored in the cloud somewhere. And our brain is simply a mechanism of getting it out of the cloud, or more importantly, he found that much of our brain is dedicated to sensory processing, visual, hearing, touch. And there really isn't a whole lot of the brain left in terms of information storage. So this really, we're making it sound like it's new, but it's not. This goes all the way back to, I guess, Alfred North Whitehead. Who...
Wait. Earlier than that, I've got to get in my plug for William James here, who toward the end of the 19th century, I think it was the 1880s, wrote his essay, Human Immortality, entirely anticipating everything you're saying now in terms of treating the brain as a receiver. He argues against the idea that we were compelled by any evidence to think of the brain as actually producing. We could just as easily And he argues that we can actually make more sense of things if we view the brain not as producing, but as receiving. That's a very sophisticated philosophical argument on the part of America's greatest philosopher. He's writing before the advent of radio, which is really, really important because for us, it's very easy to understand the transmitter receiver idea and that we, the receiver, resonate with something coming in, but its origin, its place of origin is not inside us. Of course, it occurs inside us. That's because the brain does play a function as things are now in receiving. It is the receiver, in fact. We want to keep it healthy for all those reasons, etc. But it isn't the origin. It isn't where these things are coming from. Now, William James entirely anticipates that treatment of the problem. Back then in the 1880s, I guess it was. In his highly regarded article, Human Immortality. So, and yes, others can, of course, be mentioned now. Whitehead comes only a little bit later. So didn't mean to interrupt the flow.
One of the distinctions I'm going to make here that I feel is very important is I try and separate things that are good ideas, which any number of people, based on their background, can come up with an idea, or, our memories are located somewhere. But one of the things that's beneficial of a dialogue between science and, let's call it, spirituality, is that we progressed to the point that with the case of William James, he was looking at this from a psychological point of view, and he wasn't terribly versed in the physical sciences. But he had a really great idea, but he had no way of really fleshing it out. One of the reasons why I bring up Alfred North Whitehead is he was thoroughly fascinated with James Clerk Maxwell. He felt that Maxwell's field equations, which go back to the mid-1800s, I believe, he thought they were revolutionary. And he wasn't alone in that. Einstein also thought that Maxwell's fields equations were a game changer in far as science, because what his field equations did is he defined a field as being information that was non-local and was everywhere. The concept of a field, he was speaking particularly about the electromagnetic field of electricity and magnetism. But his equations can apply to other types of fields that aren't based on the electron. But he really changed the game because he now has these equations that define a field is everywhere throughout the entire universe, and there are things happening in this field that affect our everyday existence. Albert Einstein tended to call it spooky action at a distance when he was referring to fields. And Maxwell really laid the groundwork of where I think we'll be going in our discussions as to, is there a scientific reality to a lot of these great ideas? We take James's idea of a radio or some type of receiver that's tapping into some sort of information field. Alfred North Whitehead went beyond that. He now used Maxwell equations and said that, well, the brain's electromagnetic in nature, and being that, it somehow can be plugged into the electromagnetic field equations. So what was remarkable about Whitehead is he took James's idea of an offsite store of information, and he fleshed it out with the best data that he had at the day, which was Maxwell's fields equations. And he came up with a number of things that were relevant to the brain being some type of receiver that was somehow plugged into this electromagnetic field. What Whitehead didn't have at the time was the idea of information, and the idea of information being non-local and being able to be stored in places that are essentially non-physical. We'll use that term. So I tend to look at, there are people that have good ideas that postulate the ideas of different types of fields with, can we take that information and plug it into realistic science that can give us some definitive mechanisms for what the brain might be doing, and more importantly, where is this information at, and is the place where it's at realistic to believe that it could exist?
But if we're treating all things from the point of view of information theory in just that way, doesn't that raise, and I mean this in all seriousness, this question of whether or not what's actually going on is that we're Sims in some larger, in some sense, by the way, that is the idea behind the Judeo-Christian Bible, that we are the creatures of a higher intelligence who made us, you know. Now, in information theoretical terms, it's not clear where to go with this notion of information. Could it be then that we are, in that sense, artifacts, informational artifacts of a certain kind of unity and complexity? Each one of us is such a thing. In what? In what kind of world do we find ourselves, therefore? But and I say this because I'm not so sure some of these ideas are all that pleasant, even. That's a separate issue, by the way, whether any of these ideas are pleasant to us. But we do want to ask whether there's reason to believe. Now, to get back to your point, then, it seems then that with your stress on electromagnetism, Maxwell and all of that, it seems to me in listening to you that I have to just ask flatly, do you think then that the realm of electromagnetism, which is the realm of radio, again, it's the idea of transmission of information via electromagnetic radiation, and that's what radio is it your suggestion then that the electromagnetic realm is sufficient to explain many as yet unexplained phenomena, including survival of death, that provides us with a model for understanding not only that it may be possible, but that there's actually good reason for believing that such a thing occurs? I wonder do you think that it's all a matter of electromagnetics, that it comes down again to electronics, as I suggested earlier?
Yes, the electromagnetic field is very well understood, and it gives us a good place to start. Let me just briefly go back to your mention of the Sims, because it brings up an interesting question that I think is important. First of all, we have no way of proving or even knowing we are Sims. It's unprovable. But it does bring up an interesting question in that a simulation like The Sims has to be programmed by somebody. In other words, when you play the game Sims, you are programming and controlling your Sims to do certain things, and then you let them kind of fumble around for a while and see where it goes, and then you poke them again with some other things. So it gives an interesting contrast into, that is one way people tend to think of God. He sits up in the heavens somewhere, and he tends to poke the creation every now and then with some things and see what's happening. I think that idea about God in general brings us to the point where that's really a non-productive way of looking at it. And it's also looking at it from the standpoint of intelligent design, which is very popular these days as a differentiation from creationism, is very interesting in that it takes us away from the God who pokes and prods and everything, but it does cast God in the form of a designer, that he's sitting there and he's doing something to make certain things, and then again he sits back and watches what goes on, and then he maybe designs for some more. What's bad about that? Well, it's a very interesting concept. It is literally a dead end, because when you design something, we'll take the classic example of a watch. You see a watch, you look at it, it's incredibly complex, and you go, I think it was Paley that said this, you infer a designer because of its complexity. But the watch is a dead end. When you design something, it has a capability, and that's it. A watch does not have free will. It doesn't have the ability to decide. So if we're looking at creation as a whole and our role in it, we have to account for how in the world is it that we have the ability to create, as your favorite phrase, the universe seems to be pregnant with creativity, just waiting to be born. And that's certainly how we view much of humanity. Look at all the ideas that spring out of nowhere that we're talking about right now. That does not come about from someone who designed something. There has to be more flexibility in that mechanism that can account for creativity, and design doesn't do that. A better example of what is popular today, when scientists tend to talk about the creation of the universe, and they talk about a number of properties of the universe and everything, the universe is a very unique place. As I mentioned, there's creativity within the universe itself, not to mention our creativity. Look at the creativity of an ecosystem. It would appear, and the way they describe it now is, rather than intelligent design, the universe seems to have been an informed creation. And this is where information becomes very important. In other words, design wasn't implanted in the universe, but information was. And this information can literally be creative in and of itself. And I'll take just a couple of minutes to exemplify a point here. When you're looking at information, you can have something that contains statistically, it's information rich, but it's totally meaningless. Shannon's equations on information content, he was trying to look at noise in phone lines. He wanted to differentiate the real signal from the noise. So he looked at information as being non-random. In other words, total randomness was no information, and a total defined sequence was 100% information. And he developed statistics that you could use, and you could tell what was a true signal and what was not. But I like this example for anyone who's watched Star Trek. Star Trek producers literally created a language. They brought in linguists to invent the Klingon language. And it's a usable language. It has syntax. It has everything a language has. So from Shannon's point of view, the Klingon language is information rich. But the fact that maybe only 10 people at Paramount Studios understand the meaning of Klingon means that it's information rich, but meaning poor. It is the meaning within information that is far more important. And it's these two extremes of being totally random and being totally set, with everything being 100%, there's no probability of anything. Creativity lies in the middle of that. You have to have repetition for information to remain viable, but you then also have to have randomness thrown in so that you have creativity. And when you look at information as an information resource, it is this going back and forth between redundancy and absolute, that really in the middle is where there is the richest creativity in information.
Yes, well, it's an old theme that creativity lies at the intersection between order and disorder. Somewhere along that line, and that's where. But my question is, why this can't? Why we couldn't be Sims even so? That is to say, that leads to a different kind of question. A question that arises in programming: is it possible to design something that has freedom? You made the assumption in what you were saying a few moments ago. You seem to assume that was not possible. But in an age at which we're seeing the advent of quantum computers and so forth, I bring up quantum because indeterministic events now are conceivable, are good science. A lot of science is indeterministic. It seems to me that if you start to think about quantum, using quantum methods, that you could incorporate the kinds of disorder that you're talking about, call it something, I'm not sure you always want to call it disorder, into the story that a higher intelligence than ours, or the higher than we've reached so far, because I'm thinking about something that might be coming in the next century or so. Perhaps this has already been done by our Sims makers. They have figured out how to make us. Namely, they figured out how to design somewhat creative beings. Our creativity also has its limits, but we are somewhat creative. I'm still not so sure that you've relieved my anxieties about the Sims model. That's all.
Uh, the well, it's not so much relieving your anxiety. It's a good concept, and it leads to a good philosophical discussion. But we can never ever prove we're Sims. It's the same.
Allow me to add my science fiction scenario. You've heard me say this before. We do have a way of proving it if by some chance the maker of the program, or whatever we're to call it, the game, has inserted into the game a means that we could discover finally for communicating with her or him, whoever I always revert to the idea that we're under the control of some 12-year-old in some larger reality, some 12-year-old kid. But what's wrong with this? With thinking of things in that way?
Well, nothing. You're talking about the concept of an Easter egg. Are you familiar with the term Easter egg as it relates to gaming? An Easter egg.
No, not off the top of my head. Explain.
An Easter egg is something that's a surprise. In other words, in a game, the developer will put in kind of like a little hidden surprise that if you do the right thing, it's like, oh, look at that. And the Easter egg is always, when you run into it. It kind of stands out. And this you're mentioning, is there something that the creator of The Sims could have put in that would give you a hint that you are in a simulation? And the Easter egg fits into that. If we look at our universe, one of the things that has amazed cosmologists for almost 20 years is the universe's constants seem to be incredibly fine-tuned. In other words, if the strong nuclear force was just 1 in 100 billion different, I mean, we're talking about a change in that constant that's almost minute, we would have no atoms. Gravity, if it was just slightly different, we would have no galaxies. There's almost a list of, there's somewhere between 25 and 30 of these constants that are so remarkably fine-tuned that if you change them either up or down by just the tiniest of a fraction, you would wind up with no matter, you would wind up with no atoms, you would wind up with no elements, no galaxies. So these constants I would equate to Easter eggs in a game. They're hints that are telling you that, wow, if this wasn't exactly like this, and this is information that would have been put in, and information that would have been put in with the creation of the universe during the Big Bang.
But Jeff, that becomes your version of Paley's watch. You've updated the Paley's watch argument now by suggesting that we view these things as signs that it must be an artifact. It is put together with such infinite delicacy that any Swiss watch, which is put together with great delicacy of its parts, pales into insignificance compared to the fine-tuning that you've been talking about just then. I think it's great. It seems to me then that you're using this as an argument for intelligent design, meaning by design, again, something that includes the idea of creativity in it, doesn't exclude it. I'm not talking about deterministic programming.
I would disagree with that from the point of that the constants are not where creativity comes from. And indeed, there's even thoughts.
I didn't say that. I meant that they are signs of a creative intelligence behind them to fine tune them in just such mutual accord. You said that if the strong force or the electromagnetic force, if these constants were just slightly different, things would fall apart. It couldn't cohere. But we do live in this coherent universe where things actually exist in this fine-tuned way. No, I'm not saying it's a compelling argument, but it certainly is an interesting one. The idea of these things, these constants of nature. I guess I'm not seeing it. Where are you going?
Well, I think I simply was using that as you brought up. How would we know if we were Sims living in a simulation? And I equated them to Easter eggs they are a hint that something more is going on here than a simple, this happened by accident. However, the constants are different from all the other information. Constants are not information. It is the information content of the universe that is creative, that is doing this balance between total randomness and total structure that results in the creativity, and that's totally separate from the constants themselves. So they're kind of two different things, but I see your point.
So how does human immortality, survival of death, figure into all of this? Where do we go?
Well, as we started off at the beginning, you have to first understand the information, but then if we're going to say the brain is a radio receiver or a receiver of some type, you have to have a cloud where the information is stored. We would need to have something that is capable of storing huge amounts of information. And then you can start to investigate, what does the brain do and how does it interact? If we're saying it's a receiver, what are the mechanisms that it could use to receive this information? It then must interact with wherever this cloud is at that contains the information. And more importantly, you must have a mechanism by which the information can go from the cloud into the brain. So there's a number of mechanistic things that have to bridge the gap between a good idea of, oh gosh, there's information in the universe somewhere and we're tapping into it. Well, that's the right idea. But in order for this to become a viable scientific theory, you have to then demonstrate where this might be. And that's where you go from Whitehead's rather general idea into things that are more specific. You named a couple of the people. You named David Bohm and Carl Pryburn. These are people that are looking at this problem from the mechanistic point of view. With David Bohm, he's looking at it from quantum field theory. In Carl Pryburn, he's looking at it from the function of the brain. And they actually got together, and one of the things that's impressive is they put forth together a rather detailed mechanism with all the things filled in. And it is consistent with the number of experiments that they've run. And the more they learn about quantum field theory, the more it seems to agree with that. So one has to be careful when you can be looking at a good theory, and there are several. There's Sheldrake's morphogenic fields. He postulates a memory field that goes throughout the universe that determines the structure of living things. And that's a great idea, and it does have some testable things that have proven interesting, but he doesn't supply a mechanism for it. He basically says there's this field that exists in the universe, and somehow it is able to affect embryonic development and things like that. Another good one is Ervin Laszlo, who has his acacia field, which again is very similar and is reminiscent of Sheldrake's morphogenic field, but he gives no detail of the mechanism by which his acacic field can interact with our three-dimensional world. So they're very useful in terms of their good ideas, but what concerns me more and interests me more are the people that are looking into supplying mechanisms for how this can be and how we can demonstrate, how can we experimentally test for these things. And that's where I think David Bohm and Carl Pryburn really set a high bar. But they have only looked at electromagnetic interactions. And we know that there are more fields than just the electromagnetic field. So they've given us kind of a prototype in it that makes this, ostensibly it could be a real thing, but they've only investigated one small aspect of it. And it's the most obvious because the brain is electromagnetic. You put electrodes on people's heads and you can see the electrical currents running. That's what runs through neurons. So there was a connection there. We have no idea what the morphogenic field of Sheldrake's could be, nor of Laszlo's acacic field. But at least we have something to grab a hold of when we're dealing with electromagnetic fields. They may not be the only ones, but it's the one that we have a handle that we can investigate scientifically and compare to the real world.
Well, we don't always have to have a mechanistic explanation of things in order to have good reason to believe that they're real. We understood that electricity was real before Maxwell enabled us to begin to really understand it. We didn't have the theory until we worked out the theory. So still raises the question, do we have good reason to believe from the phenomena that we do see that there are that there is the preservation of such information, that it's a reality in the universe, and that the survival of death is part of what that's all about, that the information that is us, and that we given that we are in some sense very complex networks of information, can survive in that way.
Well, here
I don't know. I don't know where it is either. Although I wanted you to go on about Bohm because I thought that his implicate order isn't that intended to be the beginning of an answer to that question of where it is. It's in the smallest pores of reality itself. It's as if reality has these smallest pores defined by the Planck constant and limits beneath which we cannot discern, but that at that level, lurking at that level, is where you find all these interconnections that we're talking about. Is that you're the one who understands this stuff better than I do?
I think yes. The answer to that is yes, but it's more than we can wrap our minds around for this small session here. But I picked Pryburn and Bohm and the electromagnetic field as that has been better worked out than the others. And as a scientist, you tend to want to only tackle one problem at a time. And that then gives you hints at where to go next. So if we can work out the most known of these, which is the electromagnetic function in the brain, that may give us hints of what other quantum fields may be involved. But before any of that really happens, we have one real problem that people have to get past. And that's one of the reasons for doing podcasts like this and the stuff we put on the Rabbit Hole group on Facebook. You brought up Scrooge, and there's one marvelous passage in Scrooge where he's presented with the ghost of Marley. And Marley says, "You don't believe in me, do you?" And Scrooge goes, No, you could be indigestion from bad food that I ate. And this represents the initial inertia that we are experiencing this, in that there's a general consensus, as Plato put it, if I can't squeeze something in my hand, it doesn't exist. You first have to acknowledge that these are areas that are worth investigating, because your first knowledge is going to come from empirical things like, oh, there's an awful lot of people that are having near-death experiences, and they're doing things and accounting for things that can't be explained. There are people that see apparitions of dead people or hear dead people. So these are, like Scrooge, get immediately discounted in that they are non-physical. Therefore, they can't be true. We have to get past the Scrooge syndrome, which means we should be paying attention to these rather than discounting them, because unless we start to look at where the empirical data that's beating us over the head with all sorts of things, anywhere from clairvoyance to near-death experiences, to people seeing apparitions of dead people, mediums that are able to communicate with dead people. All of these things tend to be poo-pooed by science as, well, we're not even going to investigate it.
But let's admit it. Part of the problem is that there is so much trash in that category. It's pervasive, and some of the things, and it seems at times that the charlatans prevail. It's hard, very, very hard to find good work, good scientific work that has been done in these areas. And I'm not sure to what extent we would evaluate this in the same way. I've looked at some of the videos, for example, that you've shown me, and I'm not so sure that I treat them as seriously. I don't know what to think sometimes when I'm confronted with people who make claims that they talked to the dead or picked up the voices of the dead inside a speaker or the like. I started to look at stuff like this. I don't know how to make the point here about the fact that you and I seem to have a different level of a different sense of whether to take such reports with any seriousness at all. I incline, as you know, to the skeptical side.
Well, and rightfully so, as do I. I probably tend to look at more bizarre things than you do just because it fascinates me. Mm-hmm. Just because I'm fascinated by it doesn't mean that I've become convinced. An excellent example just came up in one of our most recent discussions. You sent me an article on, is DNA an antenna communicating with a field, an external field? And I immediately poo-pooed it, because there's antennas are for the electromagnetic spectrum. The purpose of an antenna is the wavelength that you're receiving depends on the length and shape of the antenna, because the antenna, basically, when the electromagnetic radiation hits the antenna, it causes electrons to go up and down in the antenna, which can then be amplified by your radio or whatever. There's nothing in DNA that would remotely be sensitive as an antenna to the electromagnetic field. But then as I started to look more around, one of the things that can't be accounted for is what you mentioned in junk DNA. That's a really bad term because it's not junk, it's non-expressed DNA. In other words, it's DNA that is not called routinely to make proteins. It's just there. And typically it's been thought of, nature never throws anything out. It's a big garbage bin of unused DNA that's not being used anymore. Well, I talked to a friend of mine at the Human Genome Project at NIH just to get a little bit better feel on this. And he went, well, one of the things that was a great disappointment at the Human Genome Project was they found out that 98.5% of human DNA is junk. Human beings are only made from 1.5% of the total number, the total amount of DNA. It comes to about 20,000 to 30,000 genes.
That's a little bit shocking, but I must add that it's always been known that it was a minority of the DNA that was actually active, that the junk really was the majority. Some reports had it up at around 90%. What you're doing is saying it's not just 90%, it's more like 98%. But go ahead.
Well, and this, you look at something like a rice plant that has 5 times the amount of DNA as a human being. Now,
so what's all that DNA be? What's it there for? What's it doing?
Here's what he thought was interesting. That as they've been looking at this, they find out that the junk DNA is directly related to the, I guess you'd call it, the sentience of the species. Human beings have the most junk DNA of anything known to man. If you look at something like a plant, it has very little junk DNA.
And sentience. So that you said the word. I want to do a full stop here. You're saying that the amount of this unaccounted for, I don't want to say functionless. I'd rather say we don't know what the function of it is. And by the way, a lot of biologists admit that that's the way we should talk. We should not say it's functionless. We should say that we've figured out that one of the big uses of DNA is in making proteins. But that doesn't mean when we say we haven't figured out what this other stuff may be for, and some of us have suggested that it isn't for anything at all. They say it's functionless. Those are the people who actually call it junk. But some of us have long suggested that what we have here are things going on that we don't yet understand, and that these things are doing something, even though we haven't discovered what, in the way that we did discover what they do with respect to the production of proteins. We did discover that aspect, but there's a lot we haven't discovered. So get back then to the question now, and I might as well, as long as I have the floor for just a second, explain that this is part of my holistic thesis about the organization of the human organism, or any organism, which is that the DNA, the fact that each cell contains the complete genetic blueprint from the organism, signals the fact that each cell can communicate with each other cell, that mutual communication is going on among the parts, and that's what defines it as a true organism. Communication, then, we're back to information theory, of course, because now we're talking communication. We're talking about transmission and reception again. It's a wonderful idea, it seems to me, so I'm very excited by this direction, and that's why I myself was looking into this junk DNA thing. What's going on here?
Well, the reason why I tended to discount it was there's no real mechanism by which DNA could function as an electromagnetic antenna.
Why couldn't it be regarded as itself, just because it has all of the genome in it, as a certain kind of resonator in and of itself?
Because if you look at the function of an antenna for an electromagnetic signal, there are things in the body that can be antennas to electromagnetic radiation. Microtubules are one of them. Human capillaries are another. You have to have some channel for the wavelength to oscillate back and forth so that it functions as an antenna. DNA doesn't have that, but it's possible. One of the projected possibilities here is that the DNA is also squirreled away. DNA is protected religiously by the cell. It is not floating free in the cell. The DNA is wrapped around proteins called histones, and it's curled up and tightly protected from the environment. So that's not a good place for an antenna to be. But the one thing that I read that this man at NIH pointed me to was the sequence of the base pairs in DNA could make a resonance field with something other than electromagnetism. It could be receiving Sheldrake's morphic field. It's another mechanism we haven't explored yet, but there does seem to be a consensus as to why in the world is there so much junk DNA in human DNA and not in anything else. So it's an interesting area that probably shouldn't be discounted. It just didn't hit my radar because it didn't run in well with the electromagnetic field.
So does your friend at NIH believe that this idea that somehow or other the DNA does signal the fact that some of these other functions involving transmission actually do occur? What was his position on that matter?
Well, there are some interesting experiments that have been run with animals. We mentioned before that crystallization, growing crystals, if you're an organic chemist in the lab like I was, growing crystals was a real pain in the neck until you had managed to get the first crystals to form. And then after that, it becomes very easy. And that seems to be true worldwide. Once something is made somewhere, it becomes easier to make everywhere. This was the basis of Sheldrake's morphic fields. They've run experiments with rats that have been trained to run a maze. Once the mice or rats have successfully run the maze, they find that rats in California can run the maze without a learning curve. So there's anecdotal evidence that there does seem to be some universal memory here, that once something is obtained, it's stored somewhere and tapped into, and it seems to be, for the morphogenic field, species specific, which would lead you directly to the DNA, which would be species specific. So there are some pointers and some Easter eggs saying that may be a viable theory.
Yeah, it may be. So where are we in all of this with these maybes? What is one to believe? Becomes the question. Is there a good reason for believing that survival of death serves any function, or that there is something special about us?
Well, that is a special topic we will leave for another podcast and talk simply about survival after death. It deserves a podcast all on its own. I think we're at a pretty good place to stop here.
All right, agreed. All right, well then, thank you very much, Jeff. That's great. We'll continue from there next time.
All righty.